Hello, the video you are watching is about testing transistors. We are going to test NPN and PNP transistor. For this occasion, we have this circuit on the left side, and as we can see, we are going to draw in the Fallstad simulator this one on the right side. Let's do it. So we start from here. Let me choose the annotation. And we insert inputs and sources according to the diagram, to the sketch. We need to have a 6 volts source here. Also, we are going to add wires, one wire here and one more wire here, because we are make here 2 branches. So we're going to add a switch, which is a passive component, add switch. I'm going to add a switch here. Also, we are going to add an 100 kilo ohms resistor. We are going to double click and 100 kilo. Apply and OK. We are going to insert an active component, a transistor, which is an active component, an NPN transistor. Here we are. You see here is the collector, here is the base and the emitter. It is an NPN transistor. Also here now we're going to insert a resistor of 100 ohms. So we double click on it, 100, apply, okay, without kilo. Okay, and we're going to insert also an ammeter, which is an output, an ammeter here. Okay, we're going to connect it. And also we are going to add wires in order to close the circuit. And we are ready. As you can see here now, we have drawn this circuit. Okay, what do we have here? Here we have a common emitter. Okay, a common, here is the base. Here is the emitter. And here is the collector. Okay, on this side. Here is the collector. Okay, so this circuit, this part of the circuit here is the base emitter circuit. And this circuit is forward biased. We have here an NPN, here is a P junction. So we have put here, as you can see, the plus part of the voltage source. Okay, and we have a forward bias. The current flows through this direction and this direction, and if I increase the speed of the simulation here, you are going to realize that you see we have here a very small current flowing, and here we have an increase of current, okay, to the collector. As you can see here, we have 5.361 milliamperes. And how we are going to see how many amperes do we have here? I hover, I don't need to insert an ammeter here, just hover here to the base of the transistor, and I see on the bottom right side that I have an I to the base 53.61 microamperes. You see it is down here, but if I remove the here the hovering, okay, it is removing. So if we want, we can just put here, insert here an ammeter to see what happens. I will drag and select here. Okay, the circuit does not tell me to insert. As you can see here, the circuit, okay, does not have here an ammeter, but I will insert one. So we have here the outputs, an ammeter, and I'm going to add one more ammeter. Now, as you can see here, I have a 53.61 microamperes. And here I have a 5.361 milliamperes. Okay, and if I want to make them both to the scale of milliamperes, you are going to see that it is rounded, okay, in 0.054 milliamperes. Okay, so we have what? We have a current gain. Okay, we have a current gain. In the collector, we get almost 100 times higher value of current. Okay, let's go to the presentation again. You see here the same photo. We have done this circuit, and as a result, we want to find the current gain, which is the I to the collector above I to the base, the veta, it is a Greek veta, or HFE, as we can say it represents this symbol, the amplification factor. F is the factor when the transistor is in a common emitter configuration, okay? FE. If it was in a base, it would be FB. Now it is FE. That is the meaning of FE here. So we are going to substitute, and as you can see here, I have 5.361 milliamperes to the numerator and 0.0536 milliamperes to the denominator, or if we round it, you can see here we have 54, and you see we have 536. Because we have 6 here, we may have 5, 4. So it is almost 100 the current gain that we have in the common emitter. You see here, it is the emitter. We have grounded it. We have no resistor here. Okay. Here we have to the collector and to the base. We have resistors. Okay. But in the emitter, we do not have. It is a common emitter circuit. So if we continue now and we draw a PNP with the same way, okay, we do not need to draw again the circuit. We are going to realize that happens the same, exactly the same thing. But I'm going to draw a little bit this circuit because I want to show you a detail in how we make this arrow to be in this part of the transistor and not in this one. I'm going to draw a little bit here the circuit. Again, we use the same circuit, okay, but we are going to make a few changes, of course. I have here what kind? I have a PN and NPN transistor, and I'm going to insert a PNP. Draw active component, a PNP transistor. Okay, I insert here a PNP transistor. Okay, you see that the arrow between the base and the emitter is here, but we want to be here because we have a common emitter. And if I put here the emitter in this side, it has a resistor. I don't want to have resistor. It is grounded. So I will, it is grounded to the uh, here. Okay, you see, we need to have the arrow on this side. So I'm going to edit. I go here, right click, edit, and swap EC, the emitter collector. Okay, and this is now, you see, I have my correct drawing. Okay, but as you can see here, I have 0 milliamperes. Why? You can realize that because I have here a PNP, here, hmm, here I have a PNP, the base now is negative. It is N junction. So here I must change the polarity of my battery. Okay, so I'm going to swap. You see, when I have a zero uh, current and zero push, because as we know, the base works as a valve. So I will change the polarity here. 6, okay. And I will swap, right click, swap terminals. And now you see I have my result, which is the same with the other one. I will swap the terminals here, swap the terminals here, and it is ready. It is a PNP junction. It is a PNP transistor. You see here I have my PNP. Here it is, here is the emitter. Here is the base, which is forward biased, and here is the collector circuit. Okay, which is reverse biased. How we realize this is reverse biased? Because the collector here is positive. It is a P junction, not positive. It is a P junction, but this junction, as you can see here, is connected where? To a negative polarity voltage source. Here we have minus. Here we have positive. Okay. And as you can see also, the current flows from the positive to the negative side. Okay. So this was the presentation for the testing. We have the same gain. It is a mirroring circuit, this one. Okay. Thank you very much for watching this video. I will clear all my drawings and study well.